A very good morning to all my dear students. Welcome back to our online mathematics class. Today I am going to teach you remaining problems. 9th Roman. This entire problem based on law of exponents and 10th Roman. If a and b are rational numbers, find the values of a and b, each of the following equations. These two models are very important in our first chapter. So I found so many times these two models came in your previous papers. So here our ninth one, simplify 4th root of 81 minus 8 into 3rd root of, here 3 in V groove, here 3 is in V groove, plus 15 into 5th root of 32 plus square root of 225. Simplify 4th root of 81 minus 8 into 3rd root of 343 plus 15 into 5th root of 5 is in V groove. I found so many times these two models in your previous papers. So let's get into the topic. First one, simplify 4th root of 81 minus 8 into 3rd root of 3 is in V groove. 3 in V groove means 3rd root of. It is not multiplied with square root. 3 is in V groove. V groove means, so here 3 is in V groove. So 2 is in V groove. 5 is in V groove. So here 5 in V groove means 5th root of. Here 3 in V groove means 3rd root of. Here 4 in V groove. 4 is not multiplied with square root. So it is the 4th root of 81. 4 in V groove. Okay. 4th root of 81 minus 8 into 3rd root of 343 plus 15 into 5th root of 32 plus square root of 225. So solve this sum by using law of exponents. What are the law of exponents? Let us see. So law of exponents. So law of exponents, a power m whole power n is equals to a power m into n. So a power m by a power n is equals to a power m minus n. So a power m into a power n is equals to a power m plus n. Next, so 1 by a power minus n is equals to a power n. Next, a power m into b power m. Here powers are same. Here powers are same. A power m into b power m is equals to a into b whole power m. Okay, these are the law of exponents. Okay, so a power m whole power n is equals to a power m into n. A power m by a power n is equals to a power m minus n. A power m into a power n is equals to a power m plus n. 1 by a power minus n is equals to a power n, or a power minus n is equals to 1 by a power n. Next, a power m into b power m is equals to a into b whole power m. So here our question is, 4th root of 81, 8 into 3rd root of 343 plus 15 into fifth root of 32 plus square root of 225, right? Square root of 225. First change it into this 81 into, this is the radical form or third form. First change it into exponent form. Change it into exponent form. Here is also radical form. Change it into exponent form. So here is also exponent form. So that is equals to 81 to the power of 1 by 4. 8 into 343 to the power of 1 by 3 plus 15 into 32 to the power of 1 by 5 plus 225 to the power of 1 by 2. Square root of 225 is nothing but second root of 2 is in V group. Okay, square root of 225, it is nothing but second root of 225. It is also written in the form of 225 to the power of 1 by 2. Okay, idea here 81. So let's change it into exponent form and maintain the index as 4. So here we can take 3 to the power of 4, right? 3 to the power of 4 means 3 3s are 9, 9 3s are 27, 27 3s are 81. So change it into exponent form and maintain the index as 4. So whole to the power of 1 by 4. 1 by 4 minus 8 into, here is also 343 means 7 cube, right? 7 7s are 49, 49 7s are 343. So 7 cube whole to the power of 1 by 3 plus 15 into 32. Change it into exponent form and maintain the index as 5. Means here 2 to the power of 5. Okay, to the power of 1 by 5 plus 225. 225 means, so 15 square. Here indexes are same. Here 2, 1 by 2. Here 5, 1 by 5. Here 3, 1 by 3. Here 4, 1 by 4. So here we have to take law of exponent first rule. Okay, a power m whole power n is equals to a power m into n. So that is equals to, so here it is of the form a power m whole power n, right? So here a is equals to 3, m is equals to 4, n is equals to 1 by 4. So what is the result? A to the power of m into n, right? So here 3 to the power of 4 into 1 by 4 minus. Here is also we have to apply the first rule. So 8 into 7 to the power of 3 into 1 by 3. Okay. Next plus 15 into 2 to the power of 5 into 1 by 5 plus 15 to the power of 2 into 1 by 2. Okay, here 2 cancel, 5 cancel. So here exponents are same, exponents are same. So 4 into 1 by 4, 3 into 1 by 3, 5 into 1 by 5, 2 into 1 by 2. So here 3 cancel, 4 cancel. So result is 3 to the power of 1 means 3 minus. So 8 into 7s are, 8 7s are 56. 56 plus 15 2s are 30 plus 15. So here first we have to add these positive integers. So 30 plus 3 33, 33 plus 15 48, right? So that is equals to here 48 minus 56. So one is positive sign, one is negative sign. What we have to do? So here subtraction. So plus 48 minus 56. Result is 8. Here we have to take highest one symbol, that is minus 8. This is the final result. Next one, 10th Roman. If a and b are rational numbers, find the value of a and b in each of the following equations. My dear, I already told you. So these two models I found so many times in your previous papers. So I'll explain you first one, second one as your homework. So first one, root 3 plus root 2 by root 3 minus root 2 is equals to a plus b into, b is not in v group, b into, b is multiplied with square root, b into root 6. So we have to find the values of a and b. Here a and b are rationals. Rational means not a irrational. Irrational means not a rational. Okay. First one, root 3 plus root 2 by root 3 minus root 2 is equals to a plus b into root 6, right? First one, root 3 plus root 2 by root 3 minus root 2 is equals to a plus b into root 6. So we already know in our previous problems how to rationalize the denominator. Here denominator is an irrational number. We have to rationalize the denominator. Here rationalizing factor is here denominator is root 3 minus root 2. Rationalizing factor becomes root 3 plus root 2. Root 3 plus root 2. So we have to multiply numerator and denominator with root 3 plus root 2. So take LHS side. So here LHS root 3 plus root 2 by root 3 minus root 2 into root 3 plus root 2 by root 3 plus root 2. So here denominator of the form a minus b into a plus b, right? So denominator of the form a minus b into a plus b. So result is a square minus b square. A plus b into a minus b is equals to a square minus b square. So that is equals to, here numerator, in the numerator root 3 plus root 2 into again root 3 plus root 2 means root 3 plus root 2 whole square. So root 3 plus root 2 whole square by denominator of the form a plus b into a minus b. So a square minus b square. Here a is equals to root 3, right? Here b is equals to root 2, right? So a square means root 3 whole square. So here a square means root 3 whole square minus b square means root 2 whole square. So that is equals to, here square root, both are cancelled, square root. So it is of the form a plus b whole square, right? So a plus b whole square is equals to a square plus b square plus 2ab. So here a is equals to root 3, b is equals to root 2. So it is of the form a plus b whole square. A is equals to root 3, b is equals to root 2. So a square means root 3 whole square plus b square means root 2 whole square plus 2ab means 2 into a is equals to here root 3, right? So root 3 into b. Here b is equals to root 2. So root 2 by. So here 3 minus 2. Result is 1. Here denominator is rationalized, right? So here denominator is an irrational number. So here denominator is rationalized. The denominator is 1. It is a rational. So here square root cancel. Square root cancel. So that is equals to 3 plus 2 plus. So here 2 into root 3 into root 2. So these both are in the form of root a into root b. What is the result? Under root a into b, right? So here it is of the form root a, it is of the form root b. Result is under root a into b means here under root 3 into 2. So 2 into 3 into 2 means square root of 6 by 1. So that is equals to here 3 plus 2 is equals to 5 plus 2 into root 6. So let's compare these results with our RHS. So 5 plus 2 into root 6. So this is the LHS result. Let us compare this result with our RHS values. So 5 plus 2 root 6 is equals to a plus b into root 6. So here a is equals to 5, b is equals to 2, root 6 and root 6 is common. Result must compare with our RHS values. So here a is equals to 5, b is equals to 2. These are the final results of a and b. So here a is equals to 5, b is equals to 2, a is equals to 5, b is equals to 2. Okay, this is the final result. Okay, my dear students, 11th Roman, find the square root of 11 plus 2 into root 30. This type of problem we already done in our previous cases, right? So here 11 plus 2 into root 30, right? Find the square root of. We have to find the square root of 11 plus 2 into root 30. So first we have to split this 11 as a two-term summation, that is 5 and 6. 5 plus 6 is equals to 11, right? So here root 30, change it into two terms multiplication. So here 5 plus 6 is equals to 11, 5 into 6 is equals to 30, right? So 5 plus 6 plus 2 into 5 into 6, square root of. So here 11 is equals to 5 plus 6, 30 is equals to 5 into 6. So here it is of the form a square plus b square plus 2ab, right? A square plus b square plus 2ab. Here a is equals to root 5, b is equals to root 6. Whole square means it is of the form a plus b whole square. Here a is equals to root 5, b is equals to root 6. So try yourself. Our first chapter is over, right? So let us revise what we learned from this chapter. So here a number which can be written in the form of p by q, where p and q are integers and q is not equals to 0, is called rational numbers. This is the definition of rational numbers. A number which cannot be written in the form of p by q for any integers p comma q and q is not equals to 0 is called irrational numbers. Irrational means not a rational. Irrational means not a rational. The numbers which cannot written in the form of p by q are called irrationals. Next, the decimal expansion of rational is either terminating or non-terminating recurring. The decimal expansion of rational is terminating or recurring. The decimal expansion of irrational is neither terminating non-recurring, neither terminating, non-recurring. It have irrespective decimal formation, continuously goes on. Okay, next one. So the collection of all rational and irrational numbers are called real numbers. The combination of rational and irrational numbers are called real numbers. Okay, sixth point. There is a unique real number corresponding to every point on the number line, also corresponding to each real number. There is a unique point on the number line. Each and every real number has a unique point on the number line. Okay, next, seventh one. If Q is rational and S is irrational, then Q plus S, Q minus S, Q into S and Q by S are irrational. Irrationals are always in the form of Q plus S, Q minus S, Q into S, Q by S. So here rational and irrational combinations are always irrational. So the combinations may be in the form of Q plus S, Q minus S, Q into S, Q by S. Next, eighth point. If n is a natural number other than a perfect square, then root n is called irrational number. If n has not a perfect square, okay, so root n is called irrational number. Ninth one. So the following identities holds for positive real numbers a and b. So these formulas, so these all formulas are similar to algebraic formulas. These are all are applicable to real numbers, especially irrational numbers. Okay, so here 10th point. The rationalize the denominator of 1 by under root a plus b is, we can multiply with here denominator of the form square root of a minus b. We can multiply numerator and denominator with square root of a minus b. So here a and b are integers. Okay, so next one. So this is the topic of rationalizing the denominator. Next, 11th one. Let a is greater than 0, b is greater than 0 be the real number and p and q are rational numbers. Then these are the law of exponents. These are all are applicable to irrational numbers. These are also called as indices. These are very important formulas, my dear children. Next one, 12th one. If n is a positive integer is greater than 1 and a is the positive rational number but not nth power of any rational number, then nth root of a or a to the power of 1 by n is called surd. So here nth root of a is not a rational number. Nth root of a is not a rational number. Then this type of numbers are called surds. This is the radical form. This is exponent form. This is surd form or radical form. This is exponent form. So result is not a rational. These are the topics we discussed in this chapter. So what is real numbers? Real numbers are the combination of rational and irrational. This type of number system is called real numbers. Next, so how to represent rationals on the number line. Next, find rational in between two rationals. Find rationals in between two rationals. Next, the decimal form of rationals. So these are terminating, these are non-terminating, recurring. Next, and we discussed what is irrational numbers and identify irrational numbers on the number line. Next, successive magnification. And next one, successive magnification. The successive magnification sums are most important, my dear children. Next, operations on real numbers means Means apply algebraic formulas to our irrational numbers and rationalizing the denominator. This is most important topic in your irrationals. Next, law of exponents. How to apply this law of exponents to our irrationals? So next, exercise 1.4. Here all questions are covered with our law of exponents and rationalizing the denominator. All questions are covered with law of exponents and rationalizing the denominator. Okay, my dear students, if you have any doubts in this session, please contact my number. Thank you. Have a great day.